arc length, and central angle measure. We saw earlier that the idea of radian is to give the distance covered by the arc of a circle inside of an angle of radius 1. By using the ideas of similar figures, if we scale this figure up, these lengths will scale proportionally. So if I have a longer radius, call it r, but my angle is the same, then my distance out here, since I went from 1 to r, I multiplied by r, so I go from theta to multiply by r theta. We call this the arc length of a circle, and we represent it traditionally with the variable lowercase s. So s equals r theta is your equation for arc length. And s and r can be any kind of length units you want, but they will always end up the same. So inches, centimeters, miles, parsecs, doesn't matter, but it's going to be length units and it's going to be the same. The important thing to keep in mind is that your angle theta must be in radians. So if I am given a wedge of a circle, told that it has a central angle of 40 degrees, and it has a radius of, say, 5.5 inches, and we want to calculate that last side. Well, the first thing I need to do is take that 40 degrees and convert from degrees to radians by multiplying by pi divided by 180 degrees. And while I could do this using exact values, I have this 5.5 inches, which is a good sign to me that I'm going to want an approximate value at the end. So instead, I'm going to grab my calculator, I'm going to hit 40, I'm going to multiply times pi, I'm going to divide by 180, and I'm going to get 0.698 radians. And while I could round this, I'm going to let my calculator do the thinking for me and let it keep all of those digits. So my angle here is 0.698 ... radians. And we typically don't write a unit symbol for radians. Radians are just numbers. Then from here, arc length is the radius times the angle. So in our case, that's 5.5 inches times 0.698. So I grab my calculator again with the previous answer on the screen, and I type in 5.5 times, on this calculator, above the negative key is the word answer. So if I hit second, and then that negative key, it puts ANS on the screen. And that lets me use the number that I had previously without having to type the whole thing out. Almost every scientific calculator has a previous answer feature on it somewhere. Where it will be varies. TI calculators really like putting it above the negative key. Casio calculators tend to have their own key for previous answer because they think it's that important. Graphing calculators, it's a little bit more hidden, but it's generally there somewhere. The advantage of doing things that way is that we don't have to worry about how or when to round. There is an important topic in the application of mathematics called propagation of error, which asks the question, if I round here, how does that affect the results that I get further down? I don't want to have to deal with that this semester, so instead I'm just going to focus on making sure that my calculator keeps as many digits as it can, that I don't round on intermediate steps, and I just look at my answer and say, well, I had this number rounded to the nearest tenth, so I guess it makes sense to round my result to the nearest tenth, and we'll call it 3.8 inches.